So, hello guys. So we are starting new module that is an statistic. We will cover statistic for our college exam also, and for our interview preparation also. Like if we are applying for the data analytics or data scientist job for the data type, then in that part the statistic plays an important role. So we will learn the statistic also from that point of view also. So let's start. So first of all, why we need the statistic? First question arises in our mind, basically why we need. So it's basically needed because basically needed, like think of it, how do you decide if a cricket player is consistent or not? From what basis you can decide? We need the past data and some working on that. Another example we can see, like how do you know if an exam was difficult for everyone or for the one student? Based on the overall scores, and from that we can see who are highest and how much the difficulty is. From that we can get the average, maximum, and mean. So based on that, from the data we can find the everything, like what's the difficulty level and all that thing. So let's start now. We will cover very smoothly and slowly, so it will be helpful for everyone who are the beginners also. We are so learning from the beginning only. So, what is statistic? Statistic is the science of collecting, organizing, and analyzing the data. So, it's nothing but just the working with the data, like we collect and organize in the proper sequence and analyze the, like for as such the example we have taken, like the exam scores. From that we analyze who got the maximum and all the things like that. Doing this for the better decision, as a statistic help us to give the ranking, like in the exam score we can say, like how who got the first, second, and third. From that point, if gets the better decision and for the overall. So we are talking about data. So what's the data? Data is a fact or piece of information that can be measured as such. Like we are having the data of the student. So it won't, like for the specific subject we have multiple datas of the, because the classes consist of many students. So the for all the students data are collected in a specific file, and like that is called the data. For example, to measure the IQ of the class. So in this listed all are the IQ of the various students of the class. So it represents the student 1 IQ, student 2 IQ, student 3 IQ. So this all is the data of of the students in the class. So now we will understand first of all the types of statistics, which is the important question as per the interview. Also, they can ask that what are the types of statistics, and from this we can get a deeper understanding. So first is descriptive statistic. So it consists of organizing and summarizing the data. It organize and summarize the data. Let's see the example first. What's the descriptive statistic means? What it means. So we can take the example of like the classroom of the math student of the SAM 1. So total students are given in the question. So from this, here the various out of 100 we are considering the marks. So various marks of the students are being listed here. From this, like we can organize the data like in the increasing or decreasing order, and from that we can find what will be the average marks of the student in the class. So what's the average marks of the marks being secure being achieved by the student, like that. It can be anything like the mean, median, mode, or standard deviation. Yeah, so this shows the descriptive part of the statistic as such. So now the second type is the inferential statistics. So this technique where in we used data that we have measured to form the conclusion. So it's like the visualization part of the data. Now let's see that example for this statistic. So, like consider like example, are the mark of the student of this classroom similar to the age of the maths classroom in the college, in the college. So in this, it's showing like comparison. Comparison of this class of the classroom of the maths classroom and some another classroom, like we can take science classroom. Then it's taking the comparison of to visualize the data uh, data. So it's the example of the invitational statistics. Means we uh, mainly need to understand that the descriptive statistic is mainly used to is calculating the thing like mean, median, mode, and standard deviation. And informational statistic mainly used for the visualization part of the thing, like in the like as such covered in the Python, like in that we are visualizing using the various for graph like by using the various library we are visualizing the relation between the two parties, and how the graph look like now, what will be the trend, and all the things like it it will be covered up in the informational statistic. So now the next we will understand is the population and the sample. What's the population and what's the sample? Like we take a one we take one example in that we are selecting like the election are going on in the various part, and in that we are seeing that we have taken the Goa population. So in this part of the same this part is called the Goa as such in the Goa population. And from that specific in from whole Goa we are selecting some specific areas, that in this part what election, what who voted who, and like with in this area who got the highest vote, like that we are selecting a specific area, specific part of the Goa. Means we can say that we are selecting the small sample to get the proper information of that. So we can notation of the population is an capital N, and for the notation of sample it is an small n. So the bigger part is called the population, and the smaller part of the area is called sample, as sample is covered inside the population only. Now different types of sampling techniques. Like we are using to sample our the measures and all. so first so उसमें हम देखेंगे so we will first cover first technique is the simple random sampling. So in this we can take like a same like this is the population and the small circles are the sample. Every member of the population and has an equal chance of being selected for your sample of n. In random sampling, we every part of the group is having equal opportunity or equal chance to get selected for the sample. So picking names from a bowl, like we are playing the game, and like playing the game, and in that we need to pick one cheat from the bowl, and in that any cheat can be, all are having equal chance to be get selected or get the equal chance of being selected, like that only. So it's like as in with smaller age we play the games like that only. So jokes apart, now the next type of sampling is the stratified sampling, where population and is split into non-overlapping groups, which is called strata. Mm, so, for example, we can take the example like the gender, which is that can be the two types of genders, like male and female. If we are performing the survey and in that we select that how many male were there and how many female were there, like that from in that this can't get overlap, like we can't mix them, like it will differentiate differently only. Another example we can see is of the age group. Age group means like in that we can select a specific age group, like whatever interval we can select. So in this I have selected of the 10 10, like any one you can select also. So in this also we can't overlap, like if somebody is of 10 years and if we like also can say that he is of 5 years, and it can't, it's not the real understanding or the real meaning of the things, we can't get the proper understanding. So like age group also like 0 to 10, 10 to 20, 20 40, 40 to 100, like that one. Now, third type of the sampling is the systematic sampling. Pick every kth person on the list. Easy to apply to big groups. Like systematic means we follow some process which being predefined. Like we are saying that the kth position of the person need to be selected in our group, like that we are before selecting we are specifying the condition that we need to be fulfilled. So it's like this. Now we will see that example also. Wait, what is- so like example we can say see like a mall in survey like COVID. Survey was being conducted in that every eighth person in the mall we are surveying something, and like we are seeing that every eighth person in the survey is being is being affected by the COVID. Like that we can say that we are seeing the trends, like after the after the 1 to 8% growth and next person comes will be having COVID positive, like that type of survey we can say. Another example is like surveying every 10th shopper, like we are conducting the some business related survey. In that we are uh, seeing that the commercial and retail retail business are having the very much growth, like that part we can see. Another fourth type of sampling is the convenience sampling. In that choose people who are easy to reach. I am doing a survey related to a specific topic like data science, as I will not go to some other people who don't have the knowledge of the data science to do what the specific survey. So like a convenience sampling is some like the the sampling type in which we are having some understanding, or we are getting some highlights from the faraway points of them. In that we can say, so for, like we can take example of we can think जैसे कि हम सोच सकते हैं कि हमको अगर किसी से if we want to take the advice from the what to do after getting the degree from the B in and CS, and which field is an appropriate to do to get the job, and what's the package and all the things, like we these things we can't ask to and become student who has been already graduated, but we can ask this to only the B only the IT field students who have been graduated and who are working. So from that we can get the more powerful insights. So now next to sampling and the last sampling, which is the cluster sampling. So we as the name only suggests, divide into the cluster, like for example schools or cities, then randomly pick some clusters and use all members in them. Good for such the wide areas where the where our population is so much big. We can consider the example as choosing the random school for the surveying all students there. Like we need to still we need to conduct the survey. In that the we need to find the students' opinions, what are they doing, and all the things. So from that we can get we are selecting some specific schools for that purpose, we can say. Now the next is why to use sample instead of whole population. Why we are using the small sample. Think of it. So we are using the samples because it saves the time and money. Like we are, if we work on the whole population, then it's a like population has no limit. So it's hard to survey or measure the everyone, and it's also take the money also, like time also goes and money also goes, it's like that. Easier to work with, a sample is the simpler to collect and analyze. Yes, it's the raw data and also the small data, so it's easy for us, good enough for estimation. A well chosen sample gives the good insight about the population, as it's much much more to get the, it's much more not, but it's like fulfill our requirements for the performing the populations and all. Instead of like example, instead of asking every software engineer in country there's an salary, a company surveys 1,000 random engineer to estimate the average, like that part. So why sample size matters, like large samples or small samples. like a large sample size if we are having, then it gives the more accurate result but less variations. And small samples less less reliable and more variations in this small sample, so more variation we need to, like example, the researchers measures the average height of the people in a city. Instead of measuring everyone, they take many small samples like 50 people each. So like sample whole city, like it's the large sample size but gives some more accuracy and less variation. So he need to measure the height only, so it's easy for him, so less variation. Choosing the right sampling method. How to choose? Want to study people nationwide. So in this, we can say want to study people nationwide. So it's the bigger as such, the bigger sample, so large sample or population only we can say. So we need to use the cluster sampling or stratified also. Second is need quick results. So for that, convenience sampling and sample random sampling. Now, next part is the variables. A variable is a property one that can take on any value. We can say variable as the x, or we can say the variable of height, marks, weight, like that things. Now, types of variables, or we can say the data type also. There are the two types, quantitative and qualitative. So first of all, we will see the quantitative. It's can be measured numerically. Quantitative data is numerical data, and qualitative data is categorical data. So in quantitative data, we can see like the add, subtract, multiply, divide, all the things we can perform on our data. So example we can take is age, like we can find the uh, highest age. Another example is a weight. In that we can find out how much weight is higher from the X person or like that. After that, it is the qualitative data, which is the categorical data. So in that we can see like the gender, female and male. Based on some characteristic, we can derive categorical variables like blood group. So it is an categorical data. It, we can't count like how much blood group it's, like it's an categorical like data, like O positive, O negative, A positive, like that only. Like here the quantitative data is also of the two types, which is numerical data, and which is of two types, discrete variables and continuous variable. Discrete variable means a whole number, means having non-decimal value, no number of bank accounts we can think of. If we can't have the bank account as the 3.5 or 4.5, nothing like the point in this. Total number of children in the family. In that we cannot say like we are in family there are the 3.5 children. it's not possible. So another type is the continuous variable, which is the having the space, having the decimal point, decimal values, and it's like example height. Then we can say that our height is like 55.5, or we can say like the weight. If anybody asks, then we can say that my weight is about 50.5 kg, like that. Like blood pressure, in that also we can say that my blood pressure is around 3.3 or that, like. Now the random variable. A random variable, it's the important part of the statistic. From this question will be asked in the every, like in the exam also, in the interview also, like they are their favorite question as such, you can say. So what's the random variable? A random variable is number that represents the result of random event. Represent the result of the random event. Like example, we can say a rolling a dice. So as dice contains that 1 to 6 numbers, and if we roll it, then we are having the possibility that we get any number from 1 to 6. So it's called and random variables. Why are random variable important as such? Used in the data analytics, predictions, and decision making uh, for various purposes. Why are random variables used? Where are the random variable used? So like we can take example of the weather. In the temperature or rainfall, like we can predict what will be the temperature. Predict, but we can't get this like it will be vary, like we can not say that rain will come or not. So it's a random value, it can or it can't, yes or no type. Finance, stock price going up or down. Sports, goal score in the football, it can be like it can score goal like 5 4, any part. Medicine, chance of treatment working, it's like that. In that also the two types of random variable. Discrete random variable takes the continuous values like 0 1 2 3, like same. Flipping a coin, we can get head or tail. So head, if we take head as 1, then our output will be 1 by 2. Okay, so now after that we will cover this part. Wait, I think we can cover it today or in the next, like let's cover it. It will take hardly 10 to 15 minutes. So probability mass function in this tells us the probability for the each value. What's the probability? It tells the probability for the each value. Its property is the p of x equals to x must be greater than probability of a variable must be greater than or equals to 0. All probability must add up to 1. Like example, like coin toss, then the number of heads in one toss, what will it be? So x equals to, if we take the 0, then we can't get the head, so what will be? It's 1 by 2, we get the tail. So and probability, if we get head, then also the probability remains 0 0.5, as by adding both the probabilities their sum goes up to 1. accepted value accepted value means mean of the discrete random variable will be sigma of x into p into the probability of x. Example like the dice roll, what will be the expected value, which we need to find the mean. So first we are seeing that if we get 1, then multiply by the probability that how that what's the probability of getting the 1 on the dice. So it's 1 by 6 only. So for like that we are multiplying the 1 and 1 by 6, then plus, then we are taking the value as the 2, then what's the probability of getting the 2 on the dice, we are adding up. Like that we add up to 6, and final output will be getting is an expected value, or we can say the mean. Now it's a variance of the discrete random variable. So it's nothing, just like the variance is equals to expected x square and minus the expected value square. So for a dice, we can as such we have seen that what's the expected value, and by squaring we can get this value, and the variance we can calculate from the formula only. Like real life example we can see is the number of defective items in the batch. Another example like number of correct answer on the quiz is the variance. Continuous random variables can take any value in the interval, even in the decimal also. Height of the people or time to finish the task. Like in the finishing task, the seconds varies. So it's like that. Probability now in continuous we get the probability density function, and in the discrete we get the probability mass function. We need to differentiate that both the things. Instead of giving the probability of the exact value, PDF gives the probability of the range, so we need to use integration here. Like probability of the x between a and b, so we can find the f of x up to from a to p d of dx. Example is height of the student. Let's take x equals to height in the centimeter. Then we are seeing that one that our y between 160 to 170 is equals to area under the curve between the 160 and 170. So note that the probability of exactly 5 minutes is 0. Expected value e of x equals to minus infinity to up to infinity. X of x into f of x is an expected value. From this that like the x we can take variance of the continuous is the minus infinity to infinity, same like that only. X minus e of expected value of whole square into f of x dx. Example is time taken for the delivery. If we order something, then how the time taken to deliver the parcel at our home, then the daily temperature, then blood pressure also we can say. So from the based on the formula you can calculate the problem. So you can calculate for this, it's your practice. So now we will cover this topic in the next lecture. So thanks for watching, and if you like it, then if you enjoy it, then like the video, subscribe to my YouTube channel for more videos such like this, and keep supporting guys. Thank you.